Okay, to continue on with the cardiovascular system physiology, today we're going to talk about cardiac output. So cardiac output is just the volume of blood each ventricle pumps as a function of time. Usually in liters per minute, it's a rate. So cardiac output, we'll just go CO, cardiac output equals stroke volume, which is the amount of blood ejected by each ventricle with each beat, times the heart rate, which is the number of times the heart beats in a minute. So for example, if each ventricle has a rate of 72 beats a minute, and our stroke volume is 70 milliliters or 0.7 liters per beat, so we can do that, and it equals 5.0 liters a minute. So our cardiac output at this point with someone with 70 milliliters ejected from the ventricle with each beat and the heartbeat 72 times a minute, that means 5 liters of blood are circulating through the system at any given time. When we're exercising, our heart rate, we know our heart rate increases when we exercise, our stroke volume increases, and we can get a cardiac output during exercise. Approximately a well-trained person can be around 35 liters a minute. Sedentary, 20 to 25 liters a minute. So your cardiac output definitely ramps up under stressful situations, which leads us to the fight or flight mechanism. So as you might imagine, if you're being chased by the bear, hippo, whatever animal is trying to eat you, you want a mechanism in order to increase your heart rate so that you can increase your cardiac output early in the morning. So there's a large number of parasympathetic and sympathetic postganglionic neurons that end on our SA node. Remember, our SA node is our intrinsic pacemaker. So one of the best ways of looking at how the SA node is controlled is to look at membrane potential. We'll use millivolts. Minus 40, minus 60, just do that. 0, and then plus 60 millivolts up here. So this is our threshold potential at minus 40 at the SA node. And during normal situations, this is going to look something like this. Oh, I forgot to put time. Seconds. Well, I'll start from the last heartbeat. Comes down to 60. Hits threshold. Comes up. And we start over again. I'm just going to draw a line at 60 here. Okay, so that is at rest. This is the intrinsic beats. It would be approximately 100 beats a minute if there's no other influences on it. So this is just our SA node. So we know what's going on there. All right, but most of us during rest, we have, our heart rate is not at 100 beats a minute. We have our parasympathetic brake being applied. We have influence from the parasympathetic system, and that basically functions to slow our heart rate down, because we don't need to be beating at 100 beats a minute. We need to be beating about 60 beats a minute as we're sitting here listening. So this is going to look a little bit different. We're going to come down here below 60, and we're going to hyperpolarize the cell. And we're going to come way back out here. We're still going to overshoot 0. We're going to come back down and come below 60. And our heart rate's approximately 60 beats a minute. Right here. So you could see if we were to draw this out over the course of a minute, our heart rate we'd have fewer heartbeats per minute compared to our intrinsic pacemaker potential at 100 beats per minute. We also have a third condition. Imagine being chased by the bear right now. Your life depended on it. So our heart rate, since you're being chased, we'll be exercising, so our heart rate's going to increase. Our stroke volume's also going to increase too, but we'll talk about that next. But we want to see what happens to sympathetic stimulation of the SA node. So we know that our heart rate's going to increase, so that's going to look something like this. And we never really hyperpolarize the cell when sympathetic innervation is happening or stimulation is happening. The sympathetic system is basically beat or a fire, and be ready to go for the next one. And we know that our heart rate, our max heart rate is heart rate max equals approximately 220 minus your age. So we can say, let's say you're 20 years old, your max heart rate is around 200 per minute. So this would mean instead of this happening at 100 times a minute, this happening at about 60 times a minute. If we're going full out being chased by something, our heart rate could reach approximately 200 beats a minute. So we'll have 200 of the, if we were to stretch this out over 60 seconds, we'd have 200 of the sympathetic, 100 of the intrinsic beats at rest, and then the parasympathetic would be 60 beats there. So that is the parasympathetic and sympathetic control of the SA node.